Hey everybody, this is Alex Merced from AlexMercedCoder.dev. And what I want to do today is I want to talk about what is an API. Okay? And bottom line is that word API is a very loaded term when it comes to being a developer. So it can be very confusing of like what is an API, what isn't an API, what do people mean when they say API, because it's used in lots of different ways. So the point of this video is one, to learn the term API, what it means, how is it used, and two, different types of API web services, so SOAP, REST, GraphQL, RPC, at a high level. So that way you can at least, even if you don't know how to implement, how to create these different types of APIs, you understand what they are and what their role is. Okay, so I'm going to create like a little file for us to kind of work out of, scratch.js. And first let's just talk about the word. Okay, so the term is API. Okay, and let me just put some comments there. What does that mean? It stands for Application Programming Interface. Okay, and bottom line, really all it means is it's the way that when you do programming, you talk to a thing. Okay, so there are APIs for all sorts of things. Okay, but generally when you hear the word API, they generally use it in a couple different ways. Probably the way you hear it most often is referring to a web service. Okay, what is a web service? Well, it just means a web server. What does a server do when you go to a restaurant? They provide you a service. They give you things. They provide you things. Okay, that's what a web server does. Okay, web server provides a service. Okay, now most of the time we are aware of web servers. Mainly the main service that they deliver is delivering us like HTML documents, okay, that our browser reads, which is we would know as websites. So our browser receives HTML, it reads the HTML and generates a website in the browser. But at the end of the day, it's just bytes being sent over the internet, over IP, TCP. Okay, they're just bytes. Those bytes don't have to equal an HTML file. Okay, we see this all the time. Like we don't realize it, but every time we ask for an HTML file, our browser is also going to ask the server for JPEG files, for images or PNGs. They're going to ask for CSS files. They're going to ask for JavaScript files. So basically, the point is that a web server can deliver anything in any format. Okay, so there's a whole world of web services where the whole point of the service is to either deliver data, receive data, or both. Okay, and these are generally when people say, this is my API. So they'll say, hey, this is my application. They're referring to like their website. So think about like Facebook. Okay, but then there's like Facebook's API. Okay, which is their web service for you to be able to retrieve and send information to Facebook outside of the application or outside of like Facebook, the website. Okay, but they're referring to that as the API because the idea is that it's not so much that you have a web service that makes it an API. It's just that technically when you use the Facebook API, that is the way your application can talk to Facebook, the application programming interface. It's the way your application can interface with another application. Okay, so that's the point of API. So like when I talk about JSON, XML, all that is necessarily, it's more about how does A talk to B. Okay, creating a standard way, because the idea is that different programs can send and receive messages to each other, but if they don't know what those messages are going to look like, they can't agree on a standard way that, hey, then the communication is going to be unsuccessful. Like I can go up and talk to anybody, okay, but if I go up to somebody and talk English and they come back to me and talk Swahili, there's not going to be much communication that actually occurs. Okay, so basically when we think about individuals, people, languages are APIs. There are standards for delivering information, and generally two people who speak the same language can communicate in the same way that two applications using and applying the same API are able to communicate because they both know what the things mean. Okay, so basically APIs are just sort of standard ways of communication between applications, and generally this is done through web services, so web servers that send and receive information. Okay, so web servers sending, receiving information. Okay, another way that the word API is used is oftentimes when it comes to programmers programming, and this is more, which is not too different, but usually we're talking about like syntax here. So like, a library goes from version 1 to version 2, and they'll say, hey, this API has changed. Okay, so what they're really saying is like, hey, the standard way that you expect to use this part of this like library has changed, and going forward it's going to look like this, and we need to all agree to this standard. So if you're writing libraries, let's say like React's API changes, okay, they're just saying the way you write React changes, the way React interacts with things has changed. So if you write libraries that work around React, you're going to need to adjust your code because the standard has now changed. Okay, so for examples like the English language and all languages change over time. And if you still talk like it was the 1800s, now you're going to have a harder time communicating with people. So as the API changes, you need to adjust the way you're communicating. So if I have a library that's built to interact with React applications and React's API changes, React's syntax changes, then I have to change my library, because if not, they're not going to communicate well. Okay, but that's always the theme here. The idea is like, how do two things communicate? The idea is that they have to have an agreed upon standard. Okay, in the same way that I need to have an agreed upon language to talk to somebody else successfully. Okay, we have to have shared meaning, shared understanding, shared whatnot. Okay, so two, think of it as like library, syntax, and standards. Okay, because at the end of the day, it's still like, how does my code communicate with this tool? Okay, it's always two things communicating. Cool. But again, so basically always be careful like what context people are saying. Okay, when they say, hey, did you build a JSON API for or does Facebook have a JSON API versus, hey, React's component API changes. Okay, the first one I'm saying, hey, did you build a web server that delivers JSON data? In the second instance, I'm saying, hey, did the syntax of how I write this in React change? But either way, I'm referring to a standard of communication, standard of way that we all agree upon that my thing can talk to your thing. Okay, so now when we talk about web services, that's what I'm going to focus on going forward, now that we see those two contexts, because you're going to hear people use them in those two ways quite a bit if you're going to be a developer. And it can get quite confusing because you usually initially learn like the web service side, like, oh, what API is this thing that I can do a fetch request to and it sends me back some data. But it's again a wider term. So when it comes to this, so again, basically creating a web server that provides a service, generally sending and receiving data of some sort, okay, for some sort of intended purpose, whether it's like authenticating a thing or delivering you a list of the weather or whatever. Okay, there are different standards. Okay, the oldest standard that I'm aware of is SOAP. Okay, which is, I think was like simple. I forget what SOAP stands for, but SOAP. Okay, generally you don't see these new SOAP APIs being created anymore. Okay, but SOAP basically is standardized on a way. Basically, there's different data formats, different ways to serialize data. Okay, what do I mean by serialized data? Okay, taking information that we can express, so like my name is Alex Merced, my age is 37, and serializing that data, taking that data and expressing it into some sort of text format. That's what serialization means, saying taking this information, this thing that we agree upon, that we understand, but how do I express it in text? So SOAP uses XML. And it's not that it just uses XML. That's not the only thing that defines. It's also how you write your XML. And if you may or may not have seen XML in the past, but essentially XML looks like HTML. So it would look something like this, where basically you would have something that wraps your message, the data, called an envelope. Okay, so you would have something like that, and what this means is like, hey, this is my SOAP message, and inside of there you would have a SOAP header, which would have some data. Think of it as like a letter. You have your header that kind of gives you like a return address information, and then you would have a SOAP body. And then in here I would like deliver data. So in this case, like let's say I was delivering, user data. I might say, hey, like username, is Alex Merced. The age of the user is 37. Okay, so that's like what XML is going to look like. This is, I mean, to me, a little complicated, so it makes sense why they moved away from this. But I mean, you can kind of see it. Basically, I'm saying, hey, this is the message. here's some information about the message, and here's really what you're reading the letter for. Like when I read a letter, I'm reading the body of the letter. The purpose of it is not to read the dear somebody or the return address, but that's there because it's useful information to have there, aka the header. Okay, so that's what a SOAP message would look like, and basically a SOAP API would deliver messages sort of in this format. Okay, again, you don't really see this anymore. A lot of modern tools don't help as much to facilitate working with XML. Like if you take a look at like JavaScript and Node, there really isn't the built-in way to interpret XML. You'd have to download like third-party libraries because everything's kind of moved over to JSON. Okay, JSON is another format for serializing data. Okay, so basically, if I were to take that same information, basically all you would generally do is you just deliver the body. Okay, the JSON would just be the way you set the body, because generally you can put all the other information in the actual HTTP request, because generally that's how data is being traveled between applications. They use HTTP, and let's just show you what an HTTP message looks like. Okay, so basically when your browser, whenever any kind of web application sends a message, they send something like looks like this, and for that, let me just find like, let's go over here and say, oops, I want that over here. What I want to say is an example HTTP message. Let's see here. Show me an example. I can just copy and paste. Well, I mean, there's an example. So you see, like, it's just these text lines, and it says like, hey, I am making a post request, HTTP, and so you have all these like keys and values. Those are called headers. So essentially, all that header data could just be put in there instead of actually putting it in the payload. And then what happens, generally, there's a space. So you see how there's this blank line, and then it's on the line after that your data shows up, which would either be in XML, JSON, some other format. And generally, there's like a header. So you see here, so they have an example here. Yep, your content type. That'd be the header that tells your application, oh, this is the kind of data I sent. Okay, you may never actually see all this stuff when you write an application, because generally most tools and frameworks are built to interpret this aspect of it. So basically, you just see the other side. You just generally have some sort of interface, some sort of API in your framework on how to interact with this data that got sent in via the request. But really, when one application talks to another application via the interwebs, the internet, they're sending HTTP messages which are just text messages that look like this. Not even really text. Technically, it's binary, a buff, basically a byte buffer. So there's just this bytes that when they get interpreted, okay, with the right encoding, would be text like this, okay? Because generally you rather send binary. Binary is going to be the smallest thing you can send. So they're just generally sending the bytes over, and then you have to know, oh, this is the right text encoding for this message. Let me apply it, which I think is in there too. So if I look over here, do I see the encoding listed in here? Not in here. I don't see it at least. Oh, no, there it is, like encoding. So the data here is like how the data is encoded, and then the receiver then decodes it. Okay, and again, this is all stuff that generally you don't have to interact with, because generally all our web frameworks are literally, this is their job. Their job is to interpret this for us, so that way we don't have to worry about that part. Okay. But yeah, so basically the body could be, again, something like XML. It could be JSON. Now again, this particular message's JSON would look like this. Username AlexMerced. Oops, I did that wrong. AlexMerced. And then age 37. Okay. So that would be how a thing looks like. Now it looks a little funky because it thinks I'm writing a JavaScript file. Maybe let me just make this a text file. Rename text. There we go. Okay, so that's what JSON would look like. Okay, this is the same message. So you see, like, this is saying the same thing, username and age. But notice how much less text this uses. So you see, this is a much more compact format, which means less bytes have to travel. When we say, hey, from computer A to computer B over TCP, all those little bytes traveling over the internet network, oftentimes you hear people say over the wire, because you literally have a bunch of bytes traveling over the wire. So there's less data that has to travel over the wire, okay? Which means it's going to be faster, okay? So that's good. So everything's kind of moved towards JSON and JSON APIs, meaning web services that basically they standardize on the JSON format. Okay, that's the standard way they think they expect data to be received and sent. Okay, the old standard is XML on how data is sent and received. Okay, does it have to be either of those two? No, you could create your own text format and whatnot, but then that just means extra work for anybody who wants to build that because the tools that exist aren't built for those standards. Okay, you generally want to use widely adopted standards because there's going to be a lot of tools and it's going to be a lot easier because you don't have to reinvent the wheel. So when it comes to building a JSON API, there's generally three ways of doing it. There is REST, which is representational state transfer. And this is it's more of a standard on the way you set up. So essentially when you create a web service can oftentimes have different responses to different URLs. So basically what happens is you write a web server that listens to our HTTP request, and every HTTP request has a URL pattern. So you see here, this is just requesting slash. Okay, but it could be asking for like /cats, /user /1, whatever the URL pattern is in the HTTP request. Okay. So what you do in your web servers, you can often say, hey, if the pattern is this, then send this message back. So generally what happens with REST, you generally follow a pattern like this, because generally the idea is that your data generally follows where you have different sort of resources or models. So you might be dealing with, hey, a day of weather. That might be your model, like weather for one day. So then you might have something like this, where basically you generally have these standard routes, okay, these standard URL patterns that you respond to. So you would say, hey, create, or no, actually let's start with index. So you'd have like an index pattern, which is for like /weather, and that's specifically a GET request. So again, every HTTP message has a particular method. So GET, POST, PUT, there's all sorts of different methods that message could be. So you're saying, hey, if I were to put a GET to get weather, it should return me all the weather. Okay, not just one day's weather, but all the day's weather. Okay, then you have like a show route. So you have these like standards on like how your different what the URL pattern should be and what they should provide. So that way I know if I go to any API, generally it's going to follow the same pattern. So generally weather, and then we have a variable here for the ID. So this part of the URL is a variable, so it could be like weather1, weather2, weather3. It should get me the weather with the matching ID. Then there's going to be update, which is going to be, and then I write get over here. Actually, let me do create first. Create /weather, but except that'll be a post request. And what that does is make a new weather. And then, if I do update, it would be to /weather /variable of ID. Update the weather with the matching ID. And again, that would be a put or patch request. Either one of those generally works. Usually it's put. And then you have a delete, or actually it's called destroy. And that'd be like /weather /ID, and that would be a delete request. And that would remove the weather with the matching ID. And the idea is that if everyone follows this pattern, so basically if I create an API and there's 10 different models or resources, and generally I'm going to follow this URL pattern with each of them, it makes it really easy for someone to use my API because they kind of know what the patterns are going to be. They kind of know what to expect. Okay, so REST is sort of like standardizes on basically breaking up your different commands across many different URLs, and each URL is sort of one command. And that URL is going to give you back whatever the data is in the JSON format. That's one way to do it. The problem with REST, and it's still the most popular and probably still, most cases REST is the way to go, and I would say in most situations. What's going to happen is that sometimes you're just sending huge amounts of data, especially when you're talking about public APIs. You don't know what that specific use case is. So oftentimes with like a public API, you're sending this giant object of data because you're sending them everything they might want or need, but the user only needs a little bit, and they're getting this huge amount of data, and that takes up space and memory and all these kind of things. So they came up with like GraphQL. Okay, and basically which stands for graph query language. And the idea is that you're going to express the relationships between all your data as a graph. And a graph just means like all the individual connections between individual pieces of data. So generally what happens here is that there's only really one endpoint, okay? So essentially, basically, everything is a post request to /GraphQL, typically. Typically, there's going to be a GraphQL endpoint, and you make a post to it. And the idea is that the way you get what you want is you submit this query string. So you make a post to the /GraphQL, and typically you don't even know that you're doing that because they provide you a graph. You can download all these libraries that are GraphQL clients that do that part for you. So generally, the only thing you're thinking about when you use a GraphQL API is what's my query string. So in this case, you would use this language where I write a query like this. So I might say like, query, in this case, if I wanted to get the weather, it might be called like get weather. Okay. Actually, we'll say get all weather to make it clear. Get all weather. And then what I'll do is I'll say, hey, I don't want all the weather. I just want like the rain. I want precipitation actually. Precipitation and temperature. So I'll send a string that looks like this. So I'm saying, hey, I'm sending a query. Of these queries are defined by the web service. So whoever wrote the web service is going to define all these queries in a specific standard way. And then basically I can then specify, okay, hey, this is the query that I want, and that query returns a weather object. And from that weather object, I only want these two pieces of data. I don't want the rest. And what's nice is that, again, if you're using a public API, you don't have to get all the data. You can just get the data you need, and that's one of the big selling points of GraphQL. I can just be like, I can actually specify what data I want to get back. Okay, there's a lot of other really cool things about GraphQL, like in the sense that when you write it, it can write its own documentation automatically. There's ways you can do that with REST nowadays. Like there's some things called Swagger, which can basically self-document an API, so that way you have something you can read to tell you, hey, these are the URLs and this is what they return. So there's a lot more in that realm. Okay, so again, the difference here is, again, the way I communicate to a REST API is I use different URLs, and each URL gives me back something different, and it serves a different purpose. GraphQL, there's only one URL, and it knows what it's supposed to do based on this query string that I send. Okay, and it's going to interpret this query string based on a sort of a agreed upon language called GraphQL, graph query language, and that the web server will figure out what it needs to do based on that string. And then the last one we'll talk about is RPC, remote procedure call. Okay, and basically what this does, its goal is to try to make it where the feeling of the user, the person who's using the API, is that it feels just like they're running a function. Okay, so basically the idea is that at the end of the day, like the client, instead of having to make a post request, get request, having to think about any of this, they're going to do something like they'll just run a function on their client. They'll run a function on their front end, or that might just say get all weather, and it'll just feel like they're running a function. Okay, how do they make that happen? Generally, there's two steps. You create the backend, and again, there's a couple standards, but there's not like a standard, like RPC itself doesn't define like, hey, this is how you do it. It's just more about how does the end result look like. So basically, the idea is that if I'm using the client and I use this function, it should kind of communicate to the server without me thinking about it. Like I just wouldn't even notice that all the stuff that's happening behind the scenes, and it'll just feel like I'm using any other function in my code. Okay, that's remote procedure call. So the idea that, again, I call a function that then calls data that really itself is not doing a thing. It's really triggering a call to my server, and my server is actually doing a thing. Okay, and so there are frameworks for doing that. So that way, can be agreed upon standards for how to do this RPC thing. Okay, so there is gRPC. Okay, probably the most popular. I think it's G for the Google, because Google created it, gRPC. And the way this works is because, again, it's always about trying to figure out how does the front end and the back end kind of know what the agreed upon like standard are. Like how do they know what the functions are and all this stuff. And the way this works is that there's two things you need to be aware of. A protobuf. We'll just call it we'll just say protobuf. Okay, and protobuf is like, as I mentioned before, when you send stuff over the wire, you generally try to send encoded bytes. And so protobuf is a way to send that to an even more succinct set of bytes. So you're not sending like encoded text, you're actually sending like even further encoded like array buffers of bytes that are really going to be really tiny across the wire. So basically, one of the big selling points of gRPC is that if you just use their framework to do the thing, it's going to know how to crunch the information really small for speed. But essentially what happens is you would create a protobuf file, okay? And let me see if I can find an example of that. A proto file, gRPC. Let's see an example. Okay, yeah, so you would write a file that looks kind of like this, that describes the data that's being sent over, and Google's framework will just know how to crunch that data. They basically they know how their framework knows how to read these files, but what happens is that you would then take this proto file, and the gRPC framework will essentially generate the API for you on your web server. So you don't necessarily have to do too much. You just have to write the files. You write these protobufs, and then you basically, again, you're describing the different functions that exist on your server. So you see here, we have a service called greeter, which has these functions, and then all you have to do is write what these functions do. So you have no idea what the endpoints are. Even from the person who creates a server, you don't know what the endpoints are, nor do you care. Basically, this is going to be what creates everything. So this generates the server side and the client side, because then on the client side, on the front end, you would take that same proto file, pass it to the client library, and the client library would read the file and know, okay, hey, this is what I can do. Okay, so basically the idea is that it simplifies both the server and the client, because you just read this proto file and it's going to generate the server and it's going to generate the client, and you're going to be able to pass data in this much faster way via protobufs. Okay, so that's gRPC. Then there is tRPC, which is fairly new and getting a lot of popularity lately, especially in the TypeScript world. Well, in the TypeScript world, because that's what it's for. And the way this works is it uses TypeScript. And the idea is you would just write so let's go look up tRPC. Okay, and essentially the idea is you would just write your functions. So let me see if I can find, like, see right here, you're just writing a bunch of different functions. So you have a function called greeting. And then what happens is that when you're done, you just export the type of this router object. So you don't have to like do all the typing yourself. You just write the functions, and then you use that type definition to define your client. So I'm going to say, hey, like, here's my router. I'm going to export that type, then import that same type on the client side, and that's going to generate the client that's going to make all the calls. Okay, so you get this very type-safe experience because you get all the benefits of TypeScript. TypeScript on the client and the server will know all the functions and their arguments and their return values. So be able to give you all those type hints. So if you're using TypeScript, this is really, really nice. And it makes it really easy because once you define this, the type, basically the actual object with functions in itself, helps generate the client. So instead of creating a proto file and then defining the functions like in gRPC, you just write the functions, and the functions themselves end up defining your client. So this is like very nice. And again, when you're on the client, see, all you have to do is you just call the function. So you see here, client greeting query. Okay, so that is tRPC. But the idea is always in the front end, the user experience on the front end is going to be like they're just calling a function. They're not going to be thinking about, hey, I'm making a post request to here or a get request to here, or I have to make a fancy query string here. They're just calling a function like they're used to calling functions in their code. Okay, and then there's simple RPC, which is actually one that I created. Okay, simple RPC, here we go. And basically, this is just another RPC framework. I built this for giggles. So I just want to see if I could make one. And essentially what I did is I followed the API of, and again, now I'm using API in the term of like copying the syntax of React Redux, where essentially you have a bunch of actions, a bunch of functions that can be called. And basically what happens on the front end, you call a dispatch. So see here in the front end, the way it would work. Actually, do I have an example of how it would look like in the front end? Not I think on this side. This is the client, this is the server library. But you see, all you do is you literally just write an object with a bunch of functions, and that's it. You just write a bunch of functions. And then that's why it's called simple RPC, because it's really simple. Let's go to the simple RPC client. And then from the server side, they just run this create client function. They don't even have to pass it an object or anything. And essentially when they want to call a function, they're just going to pass that dispatch function a type, which is the function they want to call, and a payload, which are the arguments of that function. And that's it. They've called the function. And that'll trigger the call on the client side. I mean, on the server side. Okay, so that's a RPC API. Essentially, always the end goal is you just invoke functions on your client that trigger actions on your server, and you're trying to abstract away that sort of, there's this message going back and forth between server and client. You don't have to think about it. It just kind of works. Okay, it just kind of feels like it's all just one big application. Versus like, again, REST, where you actually have to kind of create all these individual requests to different URLs, versus GraphQL, where you have to kind of learn this whole query syntax. So those are sort of like the main categories. Again, you still have the old school SOAP, which you don't see too often anymore, but hopefully this gives you a nice tour of the different types of APIs and what do these terms mean, and how do they work. And yeah, so my name is Alex Merced from AlexMercedCoder.dev. If you have enjoyed this video, please leave a like and subscribe. Also make sure to check out training.alexmercedcoder.dev, where basically I have links also where you can find a lot of my content much easier. So you can click here, like depending where you are in your coding journey. Like if you're in the beginning and you want learning the tools, you can just click over here and say, hey, I want to learn more about Terminal. Find my videos on Terminal, or if you're going to, you want to learn about like a different different front end framework. Like, hey, I want to learn about React. Here's my React videos, my React blogs, so forth and so forth. And I'll keep adding to this as more content gets created. But this is just sort of an easy way to find the stuff you're probably looking for. Of course, you can always search on YouTube as well. But otherwise, have a great day and enjoy. I'll see you all later.